Variable ramp control is a crucial mechanism in automation systems, allowing precise and smooth transitions in variable values. Imagine a conveyor belt in a factory, speeding up or slowing down gradually to avoid sudden jerks. This is where variable ramp control comes into play. It's not just about changing values, it's about how those changes occur over time. Mastering this concept ensures your automation processes are efficient, reliable, and safe. But there's more to it than meets the eye. Discover the secret behind seamless variable control as we dive deeper. Imagine you're driving a car, and you need to smoothly accelerate or decelerate. This is exactly what variable ramps do in industrial automation. Siemens provides a code that generates these ramps for variables, allowing for precise control over motor speed or other parameters. By adapting this code to your specific needs, you can achieve seamless transitions without abrupt changes. This leads us to the secret behind seamless variable control, the exact logic and parameters you need to implement this in your applications. Let's dive into the theoretical mechanism of ramp generation and how you can leverage Siemens code for your projects. To adapt the Siemens code for your custom needs, you'll need to dive into the parameter configuration interface. Begin by locating the ramp settings section. Here, you'll find the ramp time parameter, which controls the duration of the ramp up and ramp down phases. Set this value according to your specific application requirements. For instance, if you need a slower ramp for precision control, increase the ramp time. Conversely, for faster transitions, decrease it. Remember, the ramp symmetry parameter ensures that the up and down ramps are balanced, which is crucial for consistent performance. Adjust this to match your system's dynamics. These settings are pivotal for tailoring the Siemens code to fit your unique operational environment. And here's why that matters. Implementing ramp code in your applications ensures smooth variable control, eliminating abrupt changes that can cause system instability. To integrate this, start by defining your ramp parameters. Set the ramp time, which is the duration over which the variable will change, and the target value. Use a loop to increment or decrement the variable value at each iteration, ensuring it reaches the target within the specified time. Remember to handle edge cases, like reaching the target value before the ramp time elapses, by adding conditional checks. This meticulous approach not only stabilizes your system but also enhances performance. Now, let's dive into the exact logic and parameters you'll need. Now, let's delve into advanced techniques for optimizing ramp performance. Imagine you're fine-tuning a high-performance engine. Every parameter counts. Start by adjusting the ramp rate. For a smoother transition, set the ramp duration to 500 milliseconds. This ensures a gradual change, reducing stress on the system. Next, fine-tune the tolerance level. A tolerance of plus or minus 1% can make a significant difference in stability. Remember, the goal is to achieve a balance between speed and precision. Also, consider implementing a deadband. This small range around the set point prevents unnecessary adjustments, conserving resources. Lastly, monitor the system's response time. If it's too slow, increase the ramp rate slightly. If it's too fast, consider a longer ramp duration. This iterative process will lead you to the optimal settings for your specific application. Now, let's discuss some common pitfalls and debugging strategies that you might encounter. One frequent issue is improper variable initialization. Always ensure your variables are initialized before use to avoid unexpected behavior. Another common mistake is overlooking timing constraints. Make sure your cycle times are appropriately set to match your application's requirements. If you encounter error code 8001, it typically indicates a communication issue, either a loose cable or outdated drivers. To resolve this, check your connections and update your drivers. Remember, meticulous attention to detail and setup and configuration can save you hours of debugging. And here's a pro tip: keep a troubleshooting checklist handy. This will not only speed up your debugging process but also ensure you don't miss any critical steps. By mastering these debugging techniques, you'll enhance your efficiency and reliability in your projects. This is the kind of in-depth knowledge that others might charge for, but here, it's yours for free. If you found this valuable, consider subscribing for more high-level, free education.